Hi to all, how are you? Today's topic is magnetic field induction on the axis of circular current carrying loop. There is one circular current carrying loop is there. On axis I want to find out the magnetic induction. This is also one of the application of Biot savart law. Let us see a circular current carrying loop. This is a circular current carrying loop. Okay, circular current carrying loop. This is a circular current carrying loop. Okay, and its axis is this one. This is a line. Pen is an axis of the circular current carrying loop. And now this is a circular current carrying loop on the axis at certain point. Okay, here I want to find out the magnetic induction. This diagram I drawn on the board. Let us see here. This is a circular current carrying coil, and at a distance x from the center of the circular current carrying coil, at a distance x I want to find out the magnetic induction. This is my aim. Okay, then for that what I have to do, this is a circular current carrying coil. It carries the current like this. Okay, and now in this current is I is the current in the loop or coil. Okay, and capital R is the radius of the coil, and x is what? X is the distance of point P on the axis. This is the axis of the coil. X is the distance of point P where we want to find out the magnetic induction from the center of the coil. Okay, and now how to find out the magnetic induction at this point? Okay, let us see here. To find out the magnetic induction at point P, we are taking the small element on the current carrying loop whose length is dl. Okay, this is a small element whose length is dl. From the element I am joining the point P, right? Okay, and its distance is smaller. At the down also I am taking one more element, right? And I am going to join the point P from the element. Okay, in order to apply the Biot savart law, this is a current carrying loop. We have to take the small element on the current carrying loop, and now if you want to find out the magnetic induction at point P, you have to join the element and point P. Then after that you have to use the formula, magnetic induction formula. That formula is nu naught I by 4 pi ideal sine theta by r square. This is the formula, right? That means in order to apply the Biot savart law, we have to take the small element on the loop, on the current carrying wire. Similarly here on the current carrying loop, we are taking the small element, and from where you want to find out the magnetic induction, you have to join that point with the element. Its distance is smaller. Look at here. Here I want to find out the B. Its distance from the element is smaller. Okay. And what is theta at here? Theta is angle between the R and dl. This is the theta. What about the theta in this case? Okay. Theta is angle between the dl and R. Look at here. This one. This is considered as loop. Okay, this is considered as loop, and now here this is the axis. This is the axis. dl I am taking the small element. This one. You take this R. This is R. Okay, okay. This is axis. Now R is what? You have to join the element and point P. Right, the point P on the axis at here. This is the element, small element, and this is R. Okay, dl is this one. dl is like this there. R is like this there. The angle between the dl and r from the figure, right? We will get 90 degree. Look at here. This is 90 degree. Okay, dl and r we will get as 90 degree. Okay. If you bend the pen like this, then also angle between the dl and r is 90 degree only. This is dl, this is r, and like this there, this is dl and this is r. Again 90 degree will be there. That means dl perpendicular to r from the figure, but it is a three-dimensional figure, but we are using 2D, that's why you cannot understood that one in the figure, right? But dl is perpendicular to r, that is theta equal 90 degree. And one more thing, we know that magnetic induction in vector form, we know that dB bar is equal nu naught by 4 pi into I into dl bar cross r bar by r cube. The meaning of this one is dB perpendicular to dl and db perpendicular to r. Why? Because if dl is along x-axis and r is along y-axis, what about I cap cross j cap? db along, we will get j cap, right? For example, db bar is equal, dl is I am taking along I cap, r is along j cap. What is the direction of the db? db is equal to I cap cross j cap is the k cap. That means db direction is along z axis, right? That means it is perpendicular to dl direction is along x axis, r direction is along y axis. What about the db direction? We are getting the along z axis. That means this one indicates that db is perpendicular to the plane containing the dl and r. That's why db is perpendicular to dl, db perpendicular to dl, and db also perpendicular to r. db perpendicular to dl. Okay, here we are getting the k cap perpendicular to I, k cap perpendicular to j. Okay, look at here. Now I want to find out the magnetic induction at point P due to this small element. That formula is nu naught by 4 pi into ideal sin theta by r square. That already we know. That is according to Biot savart, that is magnetic induction due to small element. But here, what is the direction of the magnetic induction? Magnetic induction should be along this direction. Look at here. This is r, perpendicular to r means 90 degree it should be make. Due to this small element at point P, the magnetic induction is perpendicular to r. db perpendicular to r. db is the small magnetic induction, okay, due to current element dl. db perpendicular to r and db perpendicular to dl. db perpendicular to r, that's why db direction is like this there. Okay, and now I am classifying this one due to this element db at this point. Okay, that is along the downward. It will be perpendicular to this is the small r, right? This is the small r. It is perpendicular to small r, right? That means db should be 90 degree. This is 90 degree. db perpendicular to r. You must remember this. Okay, from this equation db perpendicular to r. And now let us see. We know already r perpendicular from the figure. We write these all things. db perpendicular to dl, db perpendicular to r perpendicular to l. But r perpendicular to dl means we will get theta 90 degree. That you substitute in this equation. Then we are getting the db formula like this. And the next we will get as db is equal to nu naught by 4 pi into ideal by r square we will get. And here you must think about these things. Classification of the magnetic induction. db is the magnetic induction due to this element, this db, and this db is the magnetic induction due to this element. Two elements we are taking, one is at the top and other is at the bottom of the current carrying loop. And now here db classified into components, into two perpendicular components, right? This is db cos phi and this is db sin phi. Okay, and this angle I am taking as phi. Okay, then this is db cos phi and this is db sin phi. This is the component attached with the angle. It is always adjacent component. Adjacent component you will get by multiplying cos. Another component is sin. db cos phi, db sin phi. Next, similarly, this db also want to classify into components. Look at here. This is db split into components. Then this is db cos phi and this is db sin phi. This angle is phi. Okay, right. And this component is attached with the angle. We will get by multiplying with cos. And another component is sin. We are classifying the db into components. This is db and this angle is phi and this is db cos phi we will get, and this is db sin phi. When you observe this, db cos phi are opposite direction. They will cancel with each other, right? Due to this element, db cos phi are opposite direction, right? They will cancel with each other. But db sin phi due to this component and this component are along same direction. Like this, if you take the many elements, for every element there is an against. One more element is there. It produces the db cos phi in against. All the db cos phi components will cancel with each other, but all the db sin phi components will be along same direction due to all other elements also. Then at the moment net magnetic induction, if you want to find out that net magnetic induction, look at here. These are the db classified into components. This db is not there now. Okay, only db sin phi, db cos phi will be there. db cos phi are cancelled. Only db sin phi will be there. Now net magnetic induction I want to find out. Then how to find out? This is equation 1. and dB cos phi components, dB cos phi components are cancel with each other, cancel with each other. Then net magnetic induction, net magnetic induction at point P, what you will get? The net magnetic induction is B, okay? dB sin phi, dB sin phi, all dB sin phi we have to add, but summation dB sin phi we have to do. But instead of summation we have to use the integration, integration dB sin phi. dB is what? Magnetic induction due to small element whose length is dl. Then here we write dB formula, B is equal to integration dB is what at here, right? We substitute here, dB is nu naught by 4 pi into I dl by r square into sin phi. We have to write all the constants we have outside. Then we will get B is equal to this nu naught by 4 pi into I is a constant, small r is a constant, sin phi is a constant, I sin phi by small r square into integration dl, except dl all are constants. Then what is integration dl in the figure? Okay, integration dl is what? Then we know, but from figure, right? What is integration dl? dl is what? Small element on the circular loop. Integration dl is the full circle length. What is the full circle length? The circular current carrying loop radius is capital R. That means circumference is 2 pi r. Then we will get integration dl we will get is 2 pi capital R. Okay. And one more thing is that from figure, from triangle, right? From triangle we write one thing we have to know here. This angle I am taking as phi, but R and dB are perpendicular to each other. Okay, this angle is phi, this total angle is 90, means what about this angle? And this angle we will get is 90 minus phi. Okay, this angle I will get is 90 minus phi. This angle I will get is 90 minus phi. Why I will get 90 minus phi? Because here you know these are perpendicular, 90. When you add these two, you must get the 90. This is phi, means this is must be 90 minus phi. And these two also perpendicular, right? That means this is 90 minus phi. How much it should be there in order to get the total is 90? Right, this should be phi again. When you will write this as phi, what you will get the angle, total angle at here? This is phi, this is 90 minus phi. Total is phi plus 90 minus phi. We will get 90. Right, that means this angle from the figure we will get is phi. Okay, and for that sin phi, what we write? Sin phi. Okay. From triangle OAP we write. From triangle OAP, sin phi we write as, sin phi is the opposite side by adjacent side, hypotenuse. Phi opposite side is capital R, hypotenuse is small r. That means we write capital R by small r. This you substitute in above equation. Okay, this is the magnetic induction on the axis. We write B. These two we substitute in above equation, then we will get B formula as nu naught by 4 pi into I by r square. Sin phi formula we write, that is capital R by small r into integration dl is what? Integration dl is 2 pi r. Now we have to simplify this, then we will get answer. Right, this is phi cancel, and this 2 1 ja, 2 2 ja we will get. then we will get one thing, that nu naught I capital R into capital R square, nu naught I R square by 2 into, this is 2 R square R, 2 R cube we will get, 2 R cube. Okay, right. Next we have to simplify from figure. Same from triangle we will take OAP. It's a right angle triangle. We have to use the Pythagoras principle at here. What is Pythagoras principle? Hypotenuse square equal to this square plus this square. That means we write small r square is equal to capital R square plus x square we write. From this small r is equal to we write as capital R square plus x square whole power 3 by 2 we write. This use, sorry, not whole power 3 by 2. This r square at that side it will goes, means it will become root we write as whole power 1 by 2. This you substitute in above equation, then what you will get? Look at here, b is equal to mu naught I r square by 2 into, what is the small r at here? Small r we got as capital R square plus x square whole power 1 by 2. Okay, small r whole cube is there, we have to write whole cube. Then finally what you will get here? Mu naught I r square by 2 of r square plus x square. This is whole power 1 by 2 whole power cube. Then we write as whole power 3 by 2. Right? This is the final formula for the magnetic induction on the axis of current carrying loop. Okay, right. What is the formula? Mu naught I r square by 2 of r square plus x square whole power 3 by 2. This is the formula. Nu naught I r square by 2 of r square plus x square whole power 3 by 2. You have to remember, this is very important topic. Okay, take the screenshot and I will continue. Okay, note the every point. I am going to rub and I will continue. Okay, let us continue now. That is final formula what you got it here, magnetic induction on the axis. Right, the formula is magnetic induction on the axis of current carrying loop that we take as B suffix A, magnetic induction on the axis. Here we got as nu naught I r square by 2 of r square plus x square whole power 3 by 2. This is the formula for the magnetic induction on the axis of current carrying loop. But if you will take the coil, okay, magnetic induction B on the axis of coil which has capital N turns, right? Okay, this is the coil and I want the magnetic induction on the axis of coil. The radius of the coil is, distance is B and the radius is capital R, right? And it carries some current, the current is I. What is the formula for the magnetic induction on the axis? This is for one turn. Loop means it has only one turn, coil means it has many turns. Then magnetic induction on the axis formula we will get is, we have to multiply with N. This is for only one turn, loop means only one turn, coil means many turns are there. Then we have to multiply with number of turns. Nu naught Ni r square by 2 of r square plus x square whole power 3 by 2. This is the formula for the magnetic induction. This is equation 3. Okay, now we derived the magnetic induction on the axis. If you want to know the direction of the magnetic induction, or if you want to draw the graph between the B and X, okay, for example, I am going to draw a graph B versus X graph. How you will get? I am taking the B on y axis, X on x axis. Okay, look at here. The B is taken on y axis and X is taken on x axis. And let us consider this is a coil or the loop, and this side X you can take. Okay, and this side also you take the X. Right? And when you will go to right side, positive X will be increases. When X increases, this denominator will be increases, then B decreases. Right? That means if you go for this side, negative X will be increases, negative X will be increases. Right? And again X increases means this term will be increases, denominator, then B decreases. That means if X is 0, right, at the center X is 0, when you go to right side X increases. That means at the center X is 0, this term will become, this X0 means this term minimum. Okay, denominator is, X is the minimum value we are substituting, means denominator will get a minimum. When denominator is minimum, then the magnetic induction is maximum. Then that means magnetic induction at the X equal to 0, it is maximum. And when you will increase the X, then B decreases. Right? We will get the graph like this. Very important graph. You will get this graph for the 1 mark. Okay? B versus X. This topic is also very important. With this derivation, okay, you will get for the 3 marks. Okay? B versus X graph, this one. Now, what is the direction of the B? How to find out the B direction at a particular point? I am going to rub this and then I will continue. How to find out the magnetic induction on the axis of current carrying coil? That we derived, formula we derived, but I want the direction, because magnetic induction is a vector. Magnetic induction has the direction. Then how to find out the direction of magnetic induction on the axis of current carrying coil? Then for that, let us take the note. Okay, the first point is that, okay, first point, this is the current carrying coil. If the current is like this, there current is flows like this. Okay, current flows like this. Then I want the magnetic induction at this point X. This is a distance X. At this point I want to find out the magnetic induction. Then the radius is capital R. Then how to find out the magnetic induction? Then already we know the magnetic induction formula at here. The magnetic induction on the axis formula is what? Nu naught. If it has n turns, then nu naught Ni R square by 2 of R square plus X square whole power 3 by 2. This we derived. This is for 1 turn, this is for n turns. Okay, 2 of R square plus X square whole power 3 by 2. Okay, right. Then what is its direction? Its direction is, if it is clockwise, right, like this. If it is clockwise, then the magnetic induction is at this point. Look at here, the current is clockwise like this. If the current will show like this, curved fingers indicates the current and the thumb indicates the field. Okay, for example, if the current will be like this there in the current carrying loop, right, then the field is left side. If the current is like this there, right, look at here like this. Okay, if the current like this there, this is the direction of the current, right, circle. Then the field is this side there. If the current is this side, opposite direction, like this. Curved fingers indicates the current, thumb indicates the field. Field is this side, right? If the current goes like this, curved fingers indicates the current. Field is left side. If the current is like this, right? Then the field is right side. Like this, the field direction will be changes based on the direction of the current. Here, the field will be, if it is like this there, right? Then we have to write the field as left side. Field on the axis left side will be there. Okay, And the same thing, if the current is like this there, right, and at here the field I want, okay, at here I want the field. The current direction at this point, magnetic induction direction I want. Then for that, if the current is like this there, right, like this, at that moment the field direction will be outward, will be there, right, field direction will be outward, okay, right. And now the field formula is what? Field formula we already derived, mu naught Ni r square by 2 of r square plus x square whole power 3 by 2, right, this already we derived. This is how to find the direction by using right hand rule. Okay, next let us see what is the magnetic induction at the center of current carrying coil. One point I will tell, right, I want the magnetic induction at the center of current carrying coil. Magnetic induction at the center of current carrying coil. I want to find out the magnetic induction at the center of current carrying coil. Then how to find out? Okay, magnetic induction at the center of current carrying coil. Let us see how to find out the magnetic induction at the center of current carrying coil. Look at here. This is current carrying coil. It has some turns. Its radius is capital R. Its radius is capital R. Right. I want to find out the magnetic induction at the center. Here, I want to find out. When you want to find out the magnetic induction at the center, right? Here I want to find out. Then what about the x value in this case? If you want to find out the magnetic induction at the center, then what is the x value? Okay, on the here you want to find out means some value is there x, but here means x value decreases. Here means x value decreases. Here you want to find out the b. Then that is the magnetic induction at the center is BC. Okay, here the magnetic induction is BC. Okay, here I want to find out. Then how to find out the magnetic induction at the center? Just we have to substitute the x as 0, right? Then we will get the magnetic induction at the center. That we will take as BC, BA, magnetic induction and axis equal to magnetic induction at the center. We substitute in that. Then magnetic induction at the center is mu naught Ni r square by 2 of r square plus x we write as 0, x 0 square plus whole power 3 by 2. If we have to simplify this, magnetic induction at the center we will get as mu naught Ni r square by 2 of r square whole power 3 by 2. This r square whole power 3 by 2. 2 into 3 by 2 we will get. Then 2 will cancel. Okay, then we will get as mu naught Ni r square by 2 r cube we will get. Then again we have to simplify. Then magnetic induction at the center we will get as mu naught Ni by 2r, right? This is the formula for the magnetic induction at the center, right? But already we derived this formula in the last lecture, right? Magnetic induction at the center of current carrying coil is mu naught Ni by 2r. That already we know. Even from this also we can derive that formula. Okay. Now let us continue. I want the relation between the magnetic induction at the center and axis. Then how we can derive? I will rub and I will continue. Now let us continue. Then how we can derive the relation between the BA and BC. Okay, BA what? BA is the magnetic induction on the axis and BC is the magnetic induction at the center of current carrying coil. This is coil. It carries some current and at a distance x the magnetic induction is BA. Okay, B suffix A, and at the center the magnetic induction is B suffix C. I want the relation between the magnetic induction at the center and on the axis. What is the formula for the BA? Magnetic induction on the axis of coil magnetic induction on the axis of coil. Magnetic induction on the axis of coil is nu naught Ni r square by 2 of r square plus x square whole power 3 by 2. In this I will common the r square in denominator. If you will common the r square in the denominator, what you will get? Here r square common means 1 will remains. Here x square by r square will remains. Okay, whole power 3 by 2. What I did it here? I common the r square. If you multiply with r square, again r square plus r square into x by r square, this will cancel. Again you will get this formula, r square plus x square. Now we have to simplify this. Ba is equal to mu naught Ni r square by 2 into r square whole power 3 by 2 is r square whole power 3 by 2 and 1 plus x square by r square whole power 3 by 2 you will get. Then r square whole power 3 by 2 is what? This 2 cancel. 2 into 3 by 2. Then r cube we will get into 1 plus x square by r square whole power is 3 by 2. Now this r square and cube will cancel. Then finally we will get one formula, that is mu naught Ni by 2r into 1 plus x square by r square whole power 3 by 2 we will get. Now let us see what is mu naught Ni by 2r. It is a magnetic induction at the center, right? BC we write mu naught Ni by 2r, we write BC by 1 plus we write as x square by r square whole power 3 by 2. This is the direct relation between the magnetic induction on the axis and center. This we are getting from the formula, that is magnetic induction at the center we know already, mu naught Ni by 2r. Okay, and now this is the relation between the magnetic induction on the axis and center of current carrying coil. On the axis this is the formula, and we derived magnetic induction on the axis equal to magnetic induction at the center by 1 plus x square by r square whole power 3 by 2. Okay, and now let us see, we have to solve. Okay, look at here, the solution I want to explain it here. What is our question at here? A circular current carrying coil of radius R carrying current I, at what distance from the center of coil the magnetic field at a point on its axis is equal to 1 by 64 times of magnetic field at the center of coil. This is our question. What they are asking in the question, this is a coil, it is carrying current I and its radius is R. On the axis at certain distance, field is BA, at the center the field is BC, magnetic field. They are asking one thing, at what distance the field at a point on axis BA is equal to 1 by 64 times of field at center. At certain distance x, BA is equal to BC by 64, magnetic induction on the axis equal to 1 by 64 times of field at center. At what distance field at a point on axis BA is equal to 1 by 64 times of field at center. That means BA is equal to 1 by 64 times of BC. At what distance it will happen? This is the BA formula, this is the BC formula. You divide these two, or we already derived the relation between them, right? BA is equal to BC by 1 plus x square by r square whole power 3 by 2. In this BA is equal to, they gave BC by 64, this you substitute here, right? And BC will cancel this, then you will get 1 by 64 equal to 1 by this reciprocal equation you should write. 1 by 64 will become 64, 1 by x square plus r square whole power 3 by 2 become this one, and then you have to write this whole power 2 by 3 we have to do on both sides. Then 64 whole power 2 by 3, this one whole power 2 by 3, 3 by 2 into 2 by 3 will become 1, you will get 1 plus x square by whole power, or otherwise you take this 3 by 2 this side, then whole power 2 by 3 will become 1 plus x square by r square equals 64 into whole power 2 by 3. Then this 64 I am writing 4 cube, then this 3 will cancel, right? Then next step, 1 plus x square equal to, when this 3 cancels, 1 plus x square by r square equal to, you will get as 4 square, 4 square is 16, then 1 we will take to right side, x square by r square equal 16 minus 1, x square by r square equal 15, then r square is taken to right side, x square equal 15 r square, then x is equal to root 15 r we will get. That means at root 15 r distance, magnetic induction on the axis becomes 1 by 64 times of magnetic induction at the center. I will give one homework problem after rubbing the board. Okay, this is the last question. This is the homework question, right? Homework question. What is this? A circular coil having 100 turns. How many turns? Circular coil have 100 turns. On wire of radius 100 turns of on a wire of radius 20 centimeter each lies in xy plane. This coil lies in xy plane with its center at the origin of coordinates. The coil center is at the origin. Find the magnetic field at a point 0, 0, 20 root 3 centimeter when this coil carries current of 2 by 3, 2 by pi ampere. Okay, and do it. Send answer, okay, or the right answer in comment. Thank you for watching my lectures. If you have any doubt, you can contact me personally. Okay, thank you. This is little bit change here, that 100 turns of wire. Okay, right, thank you.